In Nuke 13, you now have access to our new suite of machine learning plugins, found in the AIR or Artificial Intelligence Research menu. In this video, we're going to talk about the CopyCat node. This node replicates custom effects by learning from a set of training images. The key concept here is that you'll feed the node a small number of before and after images, and then the node will do the hard work by learning how to copy the transformation to get from one to the other, saving you a lot of time. CopyCat has a neural network inside it. You can think of a neural network as a set of magic numbers or weights that are used to process your input image to produce an output image. But what are these weights? Well, at first, they're just random numbers, which means that your output image will also be random. The aim of CopyCat is to train the neural network, that we'll also refer to as our model, to find the perfect weights to make the input images look like the output images that you want. The way we do this is by feeding CopyCat pairs of before and after images, or as we call them, input and ground truth images. Collectively, these images are referred to as your dataset. Once your dataset is ready, you can start the iterative process of training. During training, a set of random crops are taken from your input images, processed by the current weights, and the result is compared against your ground truth. CopyCat then alters the weight values to try to minimize the difference between the two. This process is called a step, and as the plugin repeats this many times, it learns the best weights to make the input images look like the ground truth images, and saves these out in a .cat file. So let's take a look at an example. Here I want to use CopyCat to clean up the bruise from this actor's face. This sequence is about 350 frames long, so it will take a lot of time to clean up in the traditional way. You'd first have to track the eye and then match the defocus and the lighting changes. Instead, with CopyCat, we can just clean up a few frames and then use them as a dataset to train the model. We can then use this model to apply the effect to the rest of the sequence, saving us a lot of time. As a note, generating the dataset is the most important part of this process, because the higher the quality of data that you feed in, the higher quality results you're likely to get out. So here I've created our ground truth images by painting out the bruise in a couple of frames. These frames don't need to be consecutive, but they should cover the changes within the sequence. For example, I've chosen this frame with a shadow over the bruise, and this frame without. Then I've connected them to an append clip node to combine the separate images into a single sequence. As you can see, the input frames have also been piped into a matching append clip node. Be aware that you need to make sure the order of the input and ground truth sequences match, otherwise you'll run into problems later. So now we need to create a CopyCat node and connect the input pipe to the input images and the ground truth pipe to the ground truth images. And next, I'll set the location where the node will save the files it produces, including the crops contact sheet, the cat files, and the training summaries. Now before starting the training, I'll set the epochs, which is how many times the CopyCat node goes through the dataset before stopping. And now we're ready to start training. But before that, I'm just going to show you a few more options. Firstly, you can see the info knob, where you'll be able to see details like which channels CopyCat will use from the input and ground truth images. It will automatically pick whichever channels are in the upstream pipes. So if you do need to change this, you can use the shuffle or remove node. You can also see the batch size, which is the number of input and ground truth image pairs that you train with at each step. By default, this is set automatically based on your hardware resources. However, it can also be set manually in the Advanced tab, and I'll go through those options in a moment. And finally, you can see the total number of steps, which is how many training steps it will take to complete the epochs. So if you'd like to have more control over your training, you can open up the Advanced tab, where you'll find a bunch of extra options to play with. Starting from the top, you have the initial weights drop-down, This is very useful for tuning the result of a previously trained model to a new sequence. As you can see, you can choose between a checkpoint or pre-trained models such as deblur or upscale. If you select checkpoint, then you'll need to use the file browser to select a previously saved cat file. The deblur and upscale options allow you to tailor the results of these pre-trained networks to your own footage, or they can be used as a good starting point for similar tasks. Next, we have the model size drop-down, and this knob allows you to select 3 different sizes for the model architecture: large, medium, and small. The larger the model, the more complicated the tasks CopyCat can learn. However, it will take longer to train and use more GPU memory. So for this example, I'm going to select a large model. Next, you have the batch size, which, as I said earlier, is set to auto by default, but you can click and change it to manual and then enter the batch size that you want. Next, we have the crop size. This is the size of the random crops that are selected from each image at each step. While you may want to increase the crop size for high-resolution images, be aware that this will slow down the training and may make you run out of memory faster. Lastly, we have the checkpoint interval and the contact sheet interval, which allow you to set how often CopyCat saves cat files and the contact sheets to the disk. So now that we've covered all the options, we can press Start Training. A progress bar will appear with the time to complete and the number of steps, and a contact sheet will be displayed in the viewer. This contact sheet shows 3 of the selected random crops that are fed to the model at a given step. From left to right, they show the input data, the ground truth data, and the output of the model. At the beginning, the output of the model will look like structured noise. However, over time, it will start looking more and more like the ground truth image. In CopyCat, we can also visualize how the training is performing in the Graph tab. And here we can see a graph that shows the loss as the training progresses. Generally, if you see a downward trend, you can assume that the training is going as expected. It's often useful to increase the smoothness to see the overall trend, as this will smooth over fluctuations in the values. And in order to see more detail when the loss gets very low, we can tick the log scale checkbox. I'm going to pause the video here and we'll pick it back up when the training's finished. So once your training is complete, or you've stopped it to check how it's performing, you can go back to the main tab and you'll see a Create Inference button is now available for you to click. This button creates an inference node pointing to the latest cat file. And all you have to do is then plug it into the input sequence and take a look at your result. To speed up the rendering time, you can tick the Optimize for Speed and Memory checkbox. However, in some training, this may produce artifacts, so keep that in mind just in case you see some strange results. Alternatively, if you'd like to set up the inference node by yourself, all you need to do is create an inference node, navigate to your data directory folder and select the cat file that you're happy with. Keep in mind that the latest cat file is not always the best one, so you may want to experiment with these. Thanks for watching. If you want to learn more about CopyCat and Nuke, you can refer to the online documentation and tutorials at learn.foundry.com/Nuke.